Okay, well, this is from week one, class two, where I talk about the flight controls and how they work. So this is an excerpt that comes from that particular class.
Ought to do it nicely. The first thing I want to cover is how the controls that an airplane uses to fly, what controls are used. And the second thing I want to cover is, since we have presentations start next week, and some of the grading is on ethics, right? On ethics. So I need to cover some introduction to rational ethics today, even though I don't give that lecture until week 5. I give the lecture in week 4 or 5 on ethics. You can look at it, it's online if you want. But I wanted to cover at least 2 or 3 view graphs so that those people who are giving the presentation next week know what kind of ethics I'm talking about, right? What kind of ethics I'm talking about. So those are the 2 things I want to do yet in this class. And this particular thing I've got to show up here is an aircraft that shows you the 3 controls of almost all airplanes have these 3 axis controls. If I can find my trusty T-38 that I had, the controls for roll are the ailerons. They're the ailerons over here. They're the small things at the end. These big things in the middle are called flaps. You know, that's for landing. That's to change the camber of the wing for landing to give you more C-sub-L when you land. The little ones out here on the edge are called ailerons, and when the pilot moves those, again, if you have dynamic pressure, if you have enough dynamic pressure, the aircraft will roll one way or the other. So that's the control for rolling. You also control the aircraft in yaw with the rudder, the vertical fin. The vertical fin has pieces on it that are hydraulically controlled, or with cables if you're in a small airplane. They move these things over here in the back, and that gives the aircraft yaw. And he does that with his feet pedals, with 2 feet pedals, right? And he has toe brakes normally for stopping on the runway. And then the third one, which is the most important, is the pitch control. And the pitch control controls the elevator. The elevator are small little things on the horizontal stabilizer, which is this big thing in the back. They're small little things that this T-38 does not have elevators. That's very important for this airplane. We'll discuss it next class, next week, why this does not have elevators. This airplane, and when the pilot moves the stick in the cockpit, the whole surface moves. So it's called an elevon. This particular airplane is called an elevon. And big airplanes, however, they only move a small piece of the surface, which moves the elevators then on the elevator control surface will move and cause pitching motion that make the aircraft change its angle of attack. Got it? Okay, so those are the 3 things that you have to remember as we talk about when we start talking about aircraft accidents and what happens. We'll actually start doing that today. One of the really interesting things that very few people understand, especially that talk about accidents, I like to put all the journalists through this part of my course, is the horizontal stabilizer. On a big airplane, the horizontal stabilizer moves. It moves from what's called the trim. In the cockpit, the pilot has little buttons on the control wheel or on the control stick. They call it a Chinese hat in this airplane, a little Chinese hat that moves one way or the other. And that, when you move that, it moves the entire control surface. You see that? So what it does is, if the pilot's holding a lot of force, moving the elevators, he'll move the trim, and the trim will take the force away because that big control surface is going to move to give the same control input that the elevators gave. So the pilot doesn't have to work hard. You see how that works? So the thing to remember with the trim is that the trim moves the whole control surface of the plane. So we know that there's been a couple of, when I started teaching the class, the first crash occurred. So this view graph is actually from the first crash, because I started studying it immediately, because it was a trim-related crash. In other words, the 737 crash on the Lion Flight 610, out of Jakarta, it crashed and killed almost 200 people plus the crew because of the trim effects on the horizontal stabilizer. That's what happened. Now, at the time, they didn't know it. All we had to go on was the pilot had radioed back and said, it's like a roller coaster ride. It's a roller coaster ride. And he was saying, pan, pan. Pan is an almost emergency. Mayday is emergency. That means Mayday is 911. Pan would be like 8.911, right? I think I'll need help. But so things are going wrong. He's not exactly sure why, but he's going pan, pan. And then after that, We didn't hear from him. Okay. So what happened was, of course, the trim was generating control. The trim was moving the entire horizontal surface right down. The trim was pushing the airplane down into the ground, and the pilots were trying to control it by moving the elevators. You see that? So they could control it for a while. Yep, the whole surface was moving and they're pushing them down, and they control it. That's where the roller coaster ride came from. But eventually, do you see that the trim is going to win? Look at the size of the area of the horizontal surface relative to the elevators. It's going to win, isn't it? So even though they were pulling as hard as they could, and you pull hard when your life's at stake, right? You're pulling hard, the trim overcame it and they killed everything. So that's why these control surface things are important. And this is important to understand with this crash when you start talking about the cause of the accident. Because initially, Boeing and the FAA said, oh, it's the pilots. The pilots should have just disconnected the trim system. All they had to do was disconnect the trim, and it wouldn't have, and the accident wouldn't have occurred. Well, as we talk about, we'll see that that's not quite the case. So, the trim, which are little switches on a control wheel, and in a big airplane, it's actually, the first airplane actually was a 141. It's not flying anymore. It was the first 4-engine jet transport in the Air Force, came in around 1966. And I was lucky enough to be one of the first pilots flying it. But it had a trim wheel, had a trim button, but then in between the pilots had a manual trim, which was a big wheel, like a bicycle tire. Well, a big bicycle tire between the pilots, and you could grab that sucker and stop it. And the Boeing 737 has that. So the other thing that the Boeing executive said, and the FAA said, well, why didn't the pilots just grab their wheel? They could have just grabbed it and stopped it. Again, not quite that. We'll talk in depth about this accident. It's not quite that simple. But yes, there is a wheel between the pilots, and if you see it running away, you'll hear it. The wheel will start spinning, and you just go and you grab it. You might hurt yourself, but you stopped it. Then you disconnect the trim, and now you can fly it. Now you can fly it. The 141 also had hydraulic trim. They had a hydraulic control, which I don't know if modern airplanes had. It was a little button up here. You could push the button, and that would send hydraulic pressure to that. I could fly the airplane with that whole stab using this lever, right? Which is cool. I don't know if modern airplanes have that or not. I'm just emphasizing how these controls work in an aircraft and how they can get away from you, as in these two aircraft accidents, they did get away from the pilots. All right, that's the first thing I wanted to cover in the second hour. The second thing I want to cover in the second hour is an ethics introduction. This is taken a little bit out of place. This usually comes before the Manhattan Project and week 5. But since we have presenters going next week, they need to know what I will grade them on. And I'll basically be grading you on this piece, and I'm videoing myself too, so I'll put this video online so those of you who are presenting can just watch this in case someone's not here from your group. Fundamentally, the ethics that I'm going to cover, let's face it, I can't tell you about ethics. You had your own ethics. You got your own ethics when you were 5 years old from your parents and from your culture. So I can show you a code of ethics. You know, I will. I'll show you a code of ethics. And I give you case studies. But experience says it doesn't work. It doesn't work. So in week 5, we'll go into some depth into the research as to why it doesn't work and what needs to be done to fix it. But basically, in the Western world, in this part of the world, ethics evolved in the Middle Ages from the Enlightenment. And it evolved from a guy who's very special. His book is still in print from the 1500s, called Benito Spinoza. Benito Spinoza is a Sephardic Jew. His ancestors were thrown out of Spain or Portugal. They were thrown out, and he ended up in the Netherlands. And the religious wars were so violent. How violent were they? Well, you see the religious wars we got going on today, right? You see that. Today's nothing. A third of the population of Europe perished in the 100 years when the religious wars were going on. A third. Imagine what that be in the United States today. 50 million people dead. Now, this is in every country in Europe. So at the end of that time, finally, people said, let's stop. So they had the Treaty of Westphalia, and the Treaty of Westphalia basically created the template for the modern Europe. Belgium became Catholic, Netherlands became
Protestant.
England stayed Protestant, Germany was split in two, Lutherans up here, Bavarians stayed Catholic. They kind of allocated places where you could be your own religion without wiping each other out. And the deaths were horrific. There's nothing like you see on TV today or any of the wars. I mean, they'd bury people alive, they'd wipe out women and children, whole villages would be wiped out, killed. It was absolutely awful. So Spinoza, the ethics, normally when there's a crisis like that, the ethics go through a revision. And Spinoza wrote a book on rational ethics. Can we think it through? He calls the book Ethics. You can buy it on Amazon for about $12. It's still in print. 400 years. I mean, think about it. It's just amazing. And it's pretty good. It's a pretty good book. In week 5, I'll talk about it. But from that book influenced the philosophies in two branches of philosophies. One went to England, and under the guise of Jeremy Bentham, and one went to Germany under the guise of Immanuel Kant. And Jeremy Bentham, John Stuart Mill was his student. Maybe you heard of these people. They're pretty famous philosophers. They developed a set of laws based on rational ethics. The Benthamite ethics in England are called the good. What they said is, you should act so that you do what is good, pleasurable, happiness for the most people. That's what you should do. And it worked great in industrialized England, in the sweatshops of England in the 1800s. It worked great. Lots of laws were passed. So Benthamite and the philosophy of the good became what we call today humanitarianism, right? Humanitarianism or secular ethics. Secularism is humanism. And it tends to be left. It tends to operate on the left side of the spectrum. Not necessarily, but it tends to. The other one went to Immanuel Kant. Immanuel Kant took the work of Spinoza and developed what's called the ethics of the right. We should do what's right. If you do what's right, good will come out of it. Don't forget, Bentham said, do what's good. If you do what's good, right will come out of that. Kant took the opposite and said, well, do what's right. And then you'll be okay. So that ethics basically influenced John Locke. And John Locke influenced Thomas Jefferson. And Thomas Jefferson put the words of John Locke into the Declaration of Independence. So all the stuff you learned in school was basically Spinoza ethics as interpreted by Immanuel Kant through John Locke. It's very cool. And that's Kantian ethics. So those are the two ethical systems.
So what do we do with this information? Well, we have to rationally look at it, but then it's our subconscious that makes the final decision. The final decision, neuroscientists tell us, comes from deep within our subconscious. We can call that our conscience. So we can look at the ethics, rational ethics, Spinoza, the right and the good as it evolved, but our final decision is ours and ours alone. So we could look at it as a necessary condition to look at the right and the good, but then the sufficient condition is to take our subconscious as the final decision and accept that. It's individual, non-rule based, morally sufficient, arational, not irrational, but arational, comes out of the subconscious. And we can look at what Richard Feynman says about it. It's in the admission of uncertainty that there is hope for continuous motion and progress. In other words, we don't get stuck in some direction that doesn't get confined and permanently locked, as it has in so many periods of human history. So that's the deal. Good luck with this is an overview of flight controls and the ethics for the first half of the class in the flight class. Good luck in this course. Thank you.